Cookbook for the Universe 8. Relative Gravity, a Unified Framework for the Universe. Theory is theory by design. Object-oriented design allows theory to be extendable. Relative gravity explains in an object-oriented way how the universe is put together. The foundation of relative gravity (RG) lies in its bold reimagining of the universe, not as a static collection of forces and entities, but as a dynamic, interconnected system governed by relationships and evolution. Rooted in the principles of object-oriented design (OOD), RG transcends conventional frameworks by offering a model that is both extendable and transformative. This theory does not seek to dismantle the pillars of classical mechanics, but instead proposes a fresh perspective, one that opens doors to new possibilities by reframing the universe's most fundamental principles. By Ryan Carl Daly 1. Aka, Essay on Relative Gravity to describe the mechanics of the universe. The universe. 8.1 In perspective, understanding the theory. At its core, RG views the universe as a plasma of alternating currents, a vibrant, dynamic medium where forces interact through symmetry, harmonic resonance, and relational dynamics. This approach departs from traditional interpretations of gravity and the four fundamental forces, instead presenting them as derivatives of a unified symmetry. These forces, electrostrong, weak, electromagnetism, and gravity, are not separate phenomena, but contextual manifestations of an underlying order, differentiated by their interactions and scales. Symmetry serves as the cornerstone of this framework. In RG, symmetry is not static but conserved through polymorphism, adapting to the context and relationships of the entities it governs. While symmetry provides coherence, it does not preclude randomness. Instead, randomness emerges as a natural expression of deep-time processes, balancing the deterministic and the stochastic. This redefinition of gravity and forces extends beyond the familiar dichotomy of light and dark matter. In RG, the relationship between these forms of matter is akin to impedance, a concept drawn from the dynamic interplay of alternating currents. Just as impedance regulates energy flow in electrical systems, it mediates the relationships between particles, galaxies, and the manifold entities that span the cosmos. Manifolds, another foundational concept in RG, represent entities ranging from particles to galaxies as dynamic systems with shared properties and dimensions. These manifolds are not isolated. They interact and evolve, governed by harmonic resonance and iterative cycles of transformation. This perspective underscores the universe's interconnected nature, where even the smallest particle is part of a larger, dynamic tapestry. By Ryan Carl Daly 2. Cookbook for the Universe. In this framework, RG integrates the insights of ex nihilo and V-field theory to construct a holistic view of existence. Ex nihilo offers a philosophical foundation, emphasizing the emergence of order from chaos through the dimension of time. From ex nihilo, V-field theory complements this by bridging abstract forces with tangible phenomena, providing a coherent narrative for how entities and dimensions emerge and evolve. By viewing the universe as an object-oriented system, RG transforms our understanding of existence. Each entity, whether a subatomic particle or a sprawling galaxy, encapsulates its properties, behaviors, and evolutionary pathways, all while participating in a dynamic, interconnected network. This approach not only unifies the four fundamental forces but also redefines their relationships, offering a model that harmonizes classical physics with modern insights and opens the door to future discoveries. 8.1.1 Relative Mass and Energy. Einstein's renowned equation E equals mc elegantly encapsulates the relationship between energy, mass, and the speed of light. When rearranged as m equals ec, it unveils a profound implication. Mass is not an intrinsic, immutable property but rather energy normalized by the square of the speed of light. This realization redefines our understanding of matter, framing it not as static solidity, but as energy oscillating at extraordinary intensity, its tangible form governed by the universal constant c. In this light, mass emerges as a phenomenon deeply connected to its spatial and temporal context, leading to the concept of relative mass. Unlike the classical view, where mass is treated as a static quantity, relative mass is regarded as a relational property, a localized stabilization of energy influenced by the framework of spacetime. A. Mass is oscillating energy. Energy, inherently dynamic and wave-like in nature, manifests as mass through oscillatory processes that stabilize into observable forms. When reinterpreted through the formula m equals ec, mass takes on a new dimension. It behaves like an electrical signal, emphasizing its oscillatory and dynamic essence. Fq equals et. This perspective aligns seamlessly with modern physics, where particles exhibit duality, functioning as both waves and localized entities. In this framework, mass represents a standing wave or node within a broader energy continuum, stabilized through oscillations. These oscillations, governed by c, highlight the extraordinary intensity required for energy to coalesce into observable mass. This oscillatory nature provides a crucial bridge between the macroscopic and quantum realms, offering a unifying perspective on matter's behavior across scales. B. Dynamic Relativity and the Wave-like Nature of Mass. By Orion Carl Daly 3. Aka, Essay on Relative Gravity to describe the mechanics of the universe. The concept of relative mass resonates with the principles of relative gravity, which envisions the universe as a vast, interconnected system of alternating currents and oscillations. Within this grand symphony, matter emerges as a conserved, localized phenomenon, a tangible expression of energy stabilized within the framework of spacetime. Key insights include oscillation and intensity, the quadratic relationship, dynamic relativity. Mass is not static but emerges dynamically from energy interactions, its properties shaped by spacetime relationships. Wave-like essence, matter's inherent nature is oscillatory, with mass functioning as a stabilized expression of energy's dynamic interplay. C. Bridging classical and quantum realms. By treating mass as a product of oscillating energy, relative gravity bridges the gaps between classical mechanics, relativity, and quantum theory. This approach not only unifies these frameworks, but also reveals a universe far more dynamic and interconnected than previously imagined. In this model, mass is not merely a measure of matter, but a manifestation of energy's rhythmic dance and oscillatory node within the continuum of existence. This interpretation sets the stage for deeper exploration into how mass and energy shape the universe's structure and behavior, paving the way for new insights into the interconnected fabric of reality. 8.1.2 The Dance of Forces. In the vast expanse of the cosmos, every particle, planet, and star participates in a timeless dance, a choreography shaped by forces we observe yet often struggle to fully understand. This dance did not begin with a singular step, as the traditional notion of the Big Bang might suggest, but through countless iterations, energy folding upon itself, transforming and giving rise to the universe we know today. At the heart of this cosmic ballet lies gravity, not merely as Newton's steady hand or Einstein's elegant curve, but as a living force, dynamic and evolving. Imagine two dancers tethered not by visible strings but by an intrinsic rhythm, an interplay of attraction and repulsion. Their every motion is guided by an unseen conductor, time. Time, though linear in its classical conception, threads through their steps, shaping the disposition of each partner. Their movements are not random, they are governed by the four laws of relative gravity, principles rooted in observation and the inherent symmetry of the universe. A. The nature of pull. The tension between the dancers is dictated by their inherent dispositions, who they are and the energy they embody. By Orion Carl Daly 4. Cookbook for the Universe. Yet this disposition is shaped by the steps they've taken before and the rhythm of time compelling them forward. B. The role of distance. As they move closer, their attraction intensifies. As they part, their pull softens. The invisible stage of spatial time defines the evolution of their relationship. C. Leadership and balance. In some moments, one dancer leads while the other follows. In others, their energies balance perfectly, creating a shared rhythm where their center of gravity becomes a testament to their shared journey. D. Harmonic stability. When the distance between them is constant, their movements settle into a steady beat or rhythm where the disposition remains constant, as if the music itself enforces harmony. Yet these dancers, whether they are particles, planets, or galaxies, are not solitary performers. They are part of a cosmic orchestra, their individual dances weaving into the greater symphony of existence. Their push and pull, attraction and repulsion, form the fabric of reality itself. Relative gravity does not discard the classical frameworks of Newton or Kepler. Instead, it illuminates them from a new angle. Where Newton saw a force between two masses, relative gravity reveals a rhythm born of normalized mass and energy ET. Where Kepler charted planetary orbits, RG uncovers the geometry of spatial time, a stage that stretches across dimensions, framing the choreography of the cosmos. Symmetry acts as the constant composer in this grand performance. Forces, gravitational, electromagnetic, and beyond are variations on a universal theme, evolving through the polymorphism of time. The four laws of relative gravity are not immutable truths, they are observations of the universe's performance, guiding us toward a deeper understanding of the dance that binds all things. As you delve deeper into these principles, envision not just equations but partners on a stage, their steps reflecting the unity and beauty of the cosmos, a story still unfolding, one rhythm at a time. 8.1.3 Manifolds on the atomic scale. A proton-electron system. To illustrate the principles of relative gravity on an atomic scale, consider the by Orion Carl Daly 5. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Hydrogen atom, a system where the electron orbits the proton, bound by the electromagnetic force. In this dynamic interplay, the four laws of relative gravity reveal a deeper narrative of attraction, motion, and stability. A. The nature of the force. The relationship between the proton and electron is defined by their dispositions, the proton's positive charge and the electron's negative charge. This disposition persists over time, governed by the inheritance of linear time. As the electron oscillates within its probabilistic cloud, its charge relationship with the proton remains constant. B. Attraction and distance. The strength of attraction between the proton and electron is inversely proportional to their distance within spatial time. At close distances, their opposite charges generate a strong pull. However, the quantum nature of the electron prevents it from collapsing into the nucleus, maintaining a probabilistic boundary defined by spatial time. C. Energy and balance. The relative force within this system depends on the mass-energy ratios ET of the proton and electron. The proton, with its vastly greater mass-energy ratio, anchors the system, while the lighter electron S motion dominates the dynamics. This imbalance creates the observable orbital behavior. D. Harmonic stability. When the electron occupies a stable orbital or energy state, its average distance from the proton remains constant. This stability reflects a constant rate of disposition, aligning with quantum energy levels. The orbital becomes a manifestation of harmonic resonance, governed by the interplay of energy and time. In this example, the hydrogen atom becomes more than a simple particle system. It is a microcosm of the cosmic dance, where the principles of relative gravity are mirrored on the smallest scales. The electron and proton are not merely objects but participants in a dynamic relationship, their interplay reflecting the same forces that govern galaxies and black holes. Through the lens of relative gravity, the hydrogen atom exemplifies how the universe, at every scale, is a living, evolving system, a symphony where every note, no matter how small, contributes to the harmony of existence. By Orion Carl Daly 6. Cookbook for the Universe 8.1.4 Manifolds on the galactic scale. A star orbiting the galactic core. At the galactic scale, relative gravity provides a framework to understand the dynamic relationships between celestial bodies. A star orbiting the supermassive black hole at the Milky Way's core illustrates how these principles operate through the interplay of forces, energy, and time. 8.1.4.1 Scenario Overview. The gravitational interaction between a star and the supermassive black hole at the galaxy's center exemplifies a manifold relationship governed by RGS laws. This system demonstrates the intricate balance of gravitational pull, angular momentum, and spatial time. Law 1. The nature of the force is subject to the disposition of the entities. The nature of the gravitational interaction is determined by the mass of the star and its energy-matter properties, the gravitational influence of the black hole, which dominates due to its immense mass-energy ratio ET, the angular momentum inherited from the galaxy's rotational dynamics over time, which shapes the star's trajectory. The relationship between these factors defines the initial conditions and ongoing interaction between the star and the black hole. Law 2. The disposition is identified as the level of attraction and repulsion with respect to spatial time. Gravitational pull draws the star toward the black hole, while orbital velocity generates a centrifugal tendency that counteracts collapse. Spatial time at this scale refers to the vast temporal framework of galactic rotation. This spatial temporal context governs relative distances and the forces acting upon the star. The interplay of attraction and repulsion establishes a dynamic balance, maintaining the star's orbit. Law 3. The average force between entities depends on their equivalence in ET. The black hole's ET energy-time ratio far exceeds that of the star, creating an asymmetry where the black hole's influence dominates. The relative distance between the star and the black hole determines the balance point, where gravitational force and orbital velocity stabilize the star's trajectory. By Orion Carl Daly 7. Aka, Essay on Relative Gravity to describe the mechanics of the universe. This principle highlights the relational nature of forces, where energy and time contextualize the interaction. Law 4. At a constant distance, the rate of disposition is constant. In a circular orbit, the star maintains a constant distance from the black hole, resulting in a steady gravitational pull, b. uniform orbital velocity, c. a constant rate of disposition within the system's spatial-time framework. This consistency mirrors the principles of harmonic resonance, emphasizing the interconnected nature of forces and dimensions. 8.1.4.2 Unified Insights. Whether at the atomic scale, for example proton-electron systems, or the galactic scale, for example star-black hole systems, the laws of relative gravity remain consistent. They demonstrate a. symmetry across interactions, b. normalized mass-energy relationships ET, c. the influence of spatial time as a governing dimension. This model bridges microcosmic and macrocosmic phenomena, revealing the universe as a cohesive, dynamic system. The star's orbit around the galactic core exemplifies how relative gravity applies seamlessly across scales, offering a unified perspective of existence. By Orion Carl Daly 8. Cookbook for the Universe 8.1.4.3 Manifolds, the universe as a dynamic alternator. In the framework of relative gravity, Manifolds represent the fundamental entities of the universe, whether at the atomic or galactic scale, as dynamic bodies interacting within their respective dimensions. These interactions are governed by forces that, while contextually distinct, adhere to the same universal principles. This perspective transforms our understanding of the cosmos from a static construct to a dynamic alternator, a system where energy is conserved. Relationships evolve and harmony is maintained through iterative cycles. At its core, relative gravity offers a vision of the universe as a vast, interconnected system of alternating currents and resonances. It bridges the microcosmic phenomena of subatomic particles with the macrocosmic orchestration of galaxies, providing a cohesive narrative for existence. 8.1.4.4 Solar Systems Through the Lens of Relative Gravity by Orion Carl Daly 9. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. Unlike the 2D space-time curvature described by Einstein, RG envisions solar systems as dynamic systems shaped by overlapping energy fields and relational dynamics. This model redefines planetary interactions and orbits, revealing their deeper connection to the fabric of the universe. A. Dynamic energy fields. Planets within a solar system are not merely masses influenced by gravitational attraction. Instead, they exist as manifolds, localized expressions of energy interacting through overlapping fields. These energy fields are governed by harmonic resonance, which balances the push and pull of gravitational forces with the oscillatory dynamics of energy and time. This resonance creates stability within the system, allowing for predictable orbits and the preservation of the solar system as structure. B. Relational framework. Each planetary orbit emerges from a continuous interplay of energy, time, and force. This interplay creates a dynamic equilibrium where the gravitational pull of the central star balances the centrifugal tendencies of planetary motion. Adjustments in energy and time flow dynamically, ensuring that the system remains in harmony even as it evolves. C. Galactic influence. While solar systems operate as self-regulating systems, they are not isolated from the larger cosmic context. Surrounding galactic forces such as the gravitational influence of the galactic core, nearby stellar systems, and interstellar matter shape the alignment and stability of the solar system. This interconnectedness underscores the universe's vast relational framework, where local systems are influenced by and contribute to the dynamics of their larger galactic environment. By Orion Carl Daly 10. Cookbook for the Universe 8.1.4.5 Manifolds, a Bridge Between Scales. The concept of manifolds in RG unites microcosmic and macrocosmic phenomena under a single framework. At the atomic level, a manifold may represent the probabilistic interactions of an electron and proton. At the galactic level, it captures the intricate relationships between stars, planets, and black holes. Despite the differences in scale, the same principles apply. Symmetry ensures balance and coherence across interactions. Harmonic resonance governs the stability of systems from quantum states to planetary orbits. Energy conservation maintains the system's integrity, allowing for dynamic evolution without chaos. 8.1.4.6 The universe as a dynamic alternator. RG proposes that the universe functions as a dynamic alternator, a system where alternating currents of energy and oscillations create a self-regulating and evolving cosmos. This view moves beyond static models, highlighting the iterative and relational nature of existence. Conserved energy. Energy is not lost but transformed and redistributed through manifolds, ensuring continuity across scales and systems. Evolving relationships. Forces and dimensions adapt to changing conditions, allowing for the emergence of complexity and order within the universe. Unified perspective. By bridging Einstein's relativity with quantum mechanics and cosmic phenomena, RG offers a cohesive framework that unites the seemingly disparate realms of physics. Through relative gravity, we gain a deeper appreciation for the interconnectedness of all things. Whether observing the intricate dance of planets in a solar system or the evolution of galaxies, RG reveals the universe as a harmonious system of relationships, driven by energy, time, and the unifying principles of symmetry and resonance. By Orion Carl Daly 11. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 8.1.5 Core Concepts of Relative Gravity, RG. Relative gravity, RG, is a comprehensive framework that reimagines the universe as a dynamic, interconnected system. At its heart, RG unites the four fundamental forces, redefines mass and energy relationships, and introduces novel perspectives on time, equilibrium, and cosmic evolution. These principles serve as the foundation for understanding the mechanics of existence across microcosmic and macrocosmic scales. 8.1.5.1 Symmetry across forces. RG proposes that the four fundamental forces gravitational, electromagnetic, strong nuclear, and weak nuclear share an inherent symmetry. While their expressions differ depending on the context, their underlying properties remain consistent. This symmetry connects seemingly disparate phenomena, revealing a unified foundation for the interactions that govern the universe. By emphasizing this shared symmetry, RG creates a bridge between the quantum and cosmic scales, offering a cohesive view of the forces that shape existence. 8.1.5.2 Normalized mass RM and relative force RF. In RG, mass and force are redefined to highlight their relational nature. Normalized mass RM. Mass is conceptualized as RM equals ET, a dynamic property that reflects the relationship between energy and time rather than a static attribute. Relative force RF. Forces are viewed as polymorphic, inheriting universal principles, but adapting their expression based on the context. This approach aligns with the idea that gravitational and electromagnetic interactions, for instance, are variations of a shared fundamental property. 8.1.5.3 Dimension of time. Time in RG transcends the linear framework of classical physics. It is a continuum integral to the manifestation of energy mass force. Time operates cyclically, allowing for iterative transformations of phenomena, where past states influence future iterations, creating a dynamic narrative of existence. This cyclic view of time aligns with the delta phenomenon, illustrating how temporal dimensions contribute to the evolution of singularities into complex systems. By Ryan Carl Daly 12. Cookbook for the Universe 8.1.5.4 Manifolds as bodies. Entities in RG, whether subatomic particles or galaxies, are described as manifolds, dynamic systems characterized by shared properties and dimensions. These manifolds evolve through interactions, forming and reforming based on the interplay of energy and spatial time. Each manifold is expressed in dimensions xy's, shaped by its spatial context, allowing for scalable interpretations across different physical scales. 8.1.5.5 Relative equilibrium Re. RG introduces the concept of relative equilibrium Re. Re represents the balance point between entities, not as a static state but as a dynamic equilibrium governed by normalized forces. It emphasizes continuous interaction, where equilibrium is maintained through iterative adjustments in energy, time, and spatial relationships. Geometrically, Re provides a framework for understanding stable orbits, balanced forces, and harmonic interactions across systems. 8.1.5.6 Delta phenomenon. The delta phenomenon is central to RG, offering a model for cosmic evolution. It describes a cyclic process of abstraction, synthesis, and evolution where entities emerge, transform, and interact. Through this phenomenon, singularities evolve into complex systems, demonstrating how order arises from chaos. 8.1.5.7 Multiple singularities. RG challenges the conventional view of a singular Big Bang, proposing instead the existence of multiple origins or singularities. Each singularity represents a manifold, a point of infinite potential that evolves through iterations to form the structure of the universe. This approach provides a framework for understanding diverse cosmic phenomena without relying on a single origin event. By Ryan Carl Daly 13. Aka. Essay on Relative Gravity to describe the mechanics of the universe. 8.1.5.8 Spatial induction and oscillation. Forces in manifolds in RG interact like alternating currents, driven by oscillation, impedance, and resonance. Spatial induction. Energy and forces induce changes in spatial and temporal dimensions, creating a dynamic interplay that governs the evolution of systems. Oscillation. The rhythmic exchange of energy and force sustains the universe's dynamic nature, enabling stability within constant transformation. Resonance. Harmonic interactions between forces and manifolds ensure coherence, connecting entities across scales and driving the universe's iterative evolution. Core concepts of RG redefine our understanding of the universe by emphasizing relational dynamics, symmetry, and the cyclic nature of time and evolution. By integrating these principles, RG provides a unified framework that bridges traditional physics, quantum mechanics, and cosmology, inviting us to see the universe as a harmonious, ever-evolving system. Section 8.2 Alternating Currents in Space, a New Perspective on Orbital Relationships. In relative gravity RG, the dynamic interplay between celestial bodies like Earth and the Sun transcends traditional Newtonian and Einsteinian frameworks. This section reimagines the universe as a system of alternating currents AC, an electrolytic medium where forces, energy, and matter continuously evolve in cycles of exchange and transformation. 8.2.1 Currents of the Universe, an electrolytic analogy. The universe is envisioned as a vast plasma of alternating currents and electrolytic stew where energy flows dynamically through cycles of charge exchange and transformation. This perspective mirrors the mechanics of an alternator in a car or a power utility grid, with energy oscillating to sustain balance across cosmic systems. Key features include dynamic medium. Forces flow as currents through a medium shaped by symmetry, conservation, and harmonic resonance. Charge interplay. particles carry opposing charges, and their interactions are guided by harmonic distortions of vector wavelengths. Gravitational superposition. Bodies, from particles to galaxies, interact as manifolds within a shared gravitational framework, where superposition governs their relationships. By Orion Carl Daly 14. Cookbook for the Universe 8.2.1.1 Impedance and Ohm's Law. A cosmic analogy. Using Ohm's law as an analogy, RG describes the universe's energy flows in terms of voltage, current, and resistance. Voltage V represents the energy potentials driving universal interactions. Current I reflects the dynamic flow of energy and forces across manifolds. Resistance impedance R captures antimatter's role as a regulator, balancing the flow of energy and ensuring universal sustainability. This framework extends Ohm's law beyond electrical systems to explain the cosmic interplay of forces, illustrating how the universe is regulated to prevent extremes like unbounded expansion or premature collapse. 8.2.1.2 Impedance as antimatter. In RG, antimatter serves as the impedance that balances energy flows. Its role includes balancing forces. Antimatter creates a counterbalance to matter's interactions, preventing runaway accumulation of energy or mass. Regulating evolution. By introducing resistance, antimatter slows energy transformations, ensuring the universe evolves over time rather than collapsing or expanding uncontrollably. This concept ties antimatter to the universe's cyclic evolution, emphasizing its role in sustaining symmetry and coherence. 8.2.1.3 Sustaining the universe through time. The RG framework uses the Ohm's law analogy to describe how energy flows sustain the universe. Energy flow I. Energy oscillates dynamically across manifolds, interacting with matter and antimatter. Potential difference V. The energy potentials from quantum fluctuations to galactic interactions drive these oscillations. Impedance R. Antimatter regulates the flow of energy, balancing forces and preventing chaotic extremes. Time in this model acts like a cosmic circuit, threading through all entities and enabling the iterative evolution of energy and forces. 8.2.1.3.1 The consequences of impedance failure. Without the regulating role of antimatter or other forms of impedance, the universe would face catastrophic scenarios. By Orion Carl Daly 15. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Runaway expansion. Energy flows unchecked, leading to heat death and maximum entropy. Premature collapse. Gravity overwhelms the system, pulling everything into singularities. Time breakdown. Spatial time loses coherence, disrupting causality and creating chaos. Loss of symmetry. The absence of regulation dissolves the universe's structural harmony. 8.2.1.3.2 Preventing collapse through impedance. Impedance ensures the universe's sustainability by balancing energy exchange. Controlled transfers between matter and antimatter prevent runaway scenarios. Balancing energy exchange. Controlled transfers between matter and antimatter prevent runaway scenarios. Polymorphism of forces. Enabling forces like gravity, electromagnetism, and nuclear interactions to coexist and evolve without dominating one another. Cyclic evolution. Facilitating the universe's iterative balance between expansion and contraction, preserving symmetry over time. Cosmic implications. The Ohm's law analogy within RG transforms our understanding of the universe. By framing antimatter as a universal resistor, it highlights the critical role of impedance in sustaining the cosmos. This perspective reveals a universe governed by cyclical energy flows and transformations. Forces and interactions harmonized by symmetry and regulated by impedance. Time is the conduit that threads all dimensions and ensures the coherence of universal evolution. Impedance emerges as more than a regulator, it is the cornerstone of the universe's sustained existence, shaping its cycles, dimensions, and interactions. Without it, the universe risks chaos, collapse, or infinite dispersion, underscoring its pivotal role in maintaining harmony across cosmic scales. 8.2.2 Consider a photon as an alternating current. In the framework of relative gravity, a photon is conceptualized as a system akin to alternating current AC, offering a novel perspective on its behavior and propagation. This view reconciles the photon's ability to traverse vast distances at the speed of light, while exhibiting wave-particle duality upon interaction. By Orion Carl Daly 16. Cookbook for the Universe Einstein's Conservation Principle and Photon Behavior. Einstein's assertion that photons can become electrons upon interaction aligns with the conservation principles of relative gravity. Photons are not static entities, instead, they serve as carriers of energy, transitioning between wave-like and particle-like states depending on their interactions. Energy transfer. The photon's energy, primarily wave-like during propagation, manifests as matter-like behavior when it interacts with the receiver. Dynamic conservation. This interaction underscores the conservation of energy. As the photon's oscillatory nature transforms into quantized packets of energy, often associated with particles like electrons. 0 volts and wavelength, the neutral state of photons. A photon's ability to persist at 0 volts or a neutral energy state arises from its inherent oscillatory behavior, where energy constantly alternates between electric and magnetic components. Inherent oscillation. The photon's electric and magnetic fields oscillate perpendicular to each other, maintaining balance and allowing energy to transfer seamlessly without degradation. Wavelength and frequency. These oscillations are dictated by the photon's wavelength and frequency, which define its energy and interaction potential. This perspective explains the photon's stability and ability to maintain its properties over cosmic distances, even in the absence of a medium. Wave-particle duality, oscillation and interaction. The alternating current analogy provides a coherent explanation for the photon's wave-particle duality, a cornerstone of quantum mechanics. Wave-like nature. During propagation, the photon behaves like a wave with its oscillations creating a self-propagating electromagnetic field. Particle-like behavior. When the photon interacts with a receiver, for example an electron, a sensor, or the human retina, its wave function collapses into discrete energy packets, quantized photons. This process aligns with Feynman's quantum electrodynamics QED description, where energy transitions are observed as particle-like events. This duality highlights the dynamic essence of photons, existing simultaneously as waves and potential particles until interaction forces a resolution. Propagation across space, maintaining integrity. The IC analogy provides insight into how photons maintain their coherence and integrity over billions of light years. Self-propagation. The photon's oscillatory nature allows it to sustain itself through the interaction of its electric and magnetic fields, effectively creating a self-sustaining wave. By Orion Carl Daly, 17. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Alternating currents. Just as AC systems rely on alternating charges to transmit energy efficiently, photons rely on their inherent oscillations to propagate energy across the electromagnetic field. Resilience over distances. This model explains the photon's remarkable ability to traverse vast cosmic distances without losing its energy or characteristics, preserving its integrity until interaction. Viewing photons as alternating current systems revolutionizes our understanding of their behavior, duality, and resilience. This perspective integrates seamlessly with relative gravity, presenting photons as dynamic entities shaped by oscillatory principles, capable of bridging the wave-particle divide and sustaining their energy across the vastness of space. By redefining photons through the IC analogy, we gain deeper insights into their fundamental nature and their role within the interconnected fabric of the universe. 8.3 Relative properties and contextual universality. Relative gravity RG redefines the fundamental properties of the universe, viewing them as inherently contextual and relational rather than fixed absolutes. This perspective introduces a dynamic framework where physical phenomena adapt and transform according to their environments, connecting the microcosmic and macrocosmic realms through shared principles expressed polymorphically. 8.3.1 Relative time, a fluid continuum. Time, often perceived as linear and universal, is reimagined in RG as a dynamic and relative property. Its behavior shifts based on motion, gravitational forces, and the observer's frame of reference, extending Einstein's relativistic principles. Dynamic flow. Time accelerates or decelerates depending on relative velocity and gravitational intensity, as observed in phenomena like time dilation near massive celestial bodies. Cyclic nature. Beyond linear progression, time operates in cycles and iterations, driving the universe's evolution and enabling the emergence of complex structures through the delta phenomenon. This relative view positions time as an active participant in shaping energy and matter rather than a passive backdrop. (8.3.2) Relative distance, curvature and connection. In RG, distance is contextual and relational, influenced by the curvature of spacetime and the interactions of energy and forces. Spacetime curvature. Distances between entities are not absolute but shaped by gravitational fields, which bend spacetime and redefine spatial relationships. By Orion Carl Daly, 18. Cookbook for the Universe. Relational metrics. Distance is measured not as a fixed interval but as a dynamic property dependent on the entity's context, akin to navigating a curved surface rather than a straight line. This perspective reveals that spatial relationships are flexible and interconnected, adapting to the surrounding conditions. 8.3.3 Relative polarity and equilibrium. RG extends the concept of relativity to encompass polarities and states of balance, highlighting their dependence on context. Dynamic polarities, positive and negative charges, matter and antimatter, are not fixed opposites but relational properties that adapt to their environments. Contextual balance. Equilibrium is not a static state but a dynamic interplay of forces, continuously adjusted based on surrounding conditions, such as the interaction of gravity, electromagnetism, and nuclear forces. This adaptive view emphasizes the fluidity and interconnectedness of polarities and their role in maintaining the universe's harmony. 8.3.4 Polymorphism across scales. The relational framework introduced by RG underscores a fundamental unity between microcosmic and macrocosmic phenomena, achieved through polymorphism, the expression of shared principles in diverse contexts. Microcosmic polymorphism, at the particle level. Forces like electromagnetism and nuclear interactions exhibit unique behaviors while adhering to overarching principles of symmetry and conservation. Macrocosmic polymorphism. At the cosmic scale, these same principles govern celestial mechanics, galactic dynamics, and cosmic evolution, expressed through gravitational waves, orbital harmonics, and energy distributions. This approach bridges the apparent divide between the quantum and the cosmic, demonstrating that both realms operate under a single cohesive framework. By reframing time, distance, polarity, and equilibrium as relative and contextual, RG transforms our understanding of physical properties into a dynamic, interconnected narrative. This relational perspective not only unites the micro and macro scales, but also reveals the universe as a polymorphic system, fluid, adaptive, and bound by shared principles that express themselves uniquely across contexts. This insight forms the foundation for RG's unified framework, encouraging a deeper exploration of the interwoven fabric of existence. By Ryan Carl Daly, 19. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. By Ryan Carl Daly, 20. Cookbook for the Universe. By Ryan Carl Daly, 21. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 8.4 Relative Gravity, Emerging Galaxies and the Abstract Principles. Relative gravity RG provides a robust framework to analyze complex cosmic phenomena, such as merging galaxies, through its core principles as outlined in the abstract. The merging of galaxies can be visualized as an intricate interplay of potential energy, resonant frequency, and kinetic expressions, governed by their unique dispositions and superpositional dynamics. By Ryan Carl Daly, 22. Cookbook for the Universe. 8.4.1 Potential energy and resonant frequency. A. Definition and context. Potential energy in RG is described as the amplitude of kinetic energy within a spatial-time continuum, shared as a resonant frequency potential between bodies. Application to merging galaxies. As two galaxies A and B approach each other, their gravitational fields interact, creating a shared potential energy field. This field is expressed as a resonant frequency, reflecting the combined dynamics of their masses, velocities, and spatial configurations. The amplitude of kinetic energy increases as the galaxies accelerate toward each other due to mutual gravitational attraction. B. Visualizing the interaction. The galaxy's gravitational potential energy transitions into kinetic energy as they draw closer, creating dynamic oscillations in their spatial-temporal framework. Their shared resonant frequency governs these oscillations, harmonizing their relative motions and influencing their eventual merger. 8.4.2 Superposition and shared fundamentals. A. Definition and context. Superposition in RG is understood as the resultant amplitude formed by the vector sum of two or more waves at a point in a medium, measured through their level of alignment or coherence. Application to merging galaxies. The galaxy's gravitational fields can be treated as overlapping waveforms in a medium, where their superposition defines their interaction. At points of constructive interference, the gravitational pull intensifies, accelerating matter and energy exchange. Destructive interference zones create regions of lower interaction, leading to voids or reduced matter density. B. Physics rule for point charges. The principle of superposition for point charges states that the resultant force at a point is the vector sum of individual forces. Similarly, in merging galaxies, the resultant gravitational field at any point is the vector sum of the individual gravitational fields of the two galaxies. This superposition governs the dynamics of star systems, gas clouds, and dark matter halos within the galaxies, shaping the emergent structure of the new system. By Ryan Carl Daly, 23. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 8.4.3 Kinetic Expression and Unique Dispositions. Definition and context. The kinetic expression in RG is subject to the unique dispositions of the interacting bodies, reflecting their inherent characteristics such as mass, velocity, and rotational dynamics. Application to merging galaxies. Each galaxy brings its distinct disposition, Galaxy A, larger mass, slower rotational velocity, dominated by an elliptical structure. Galaxy B, smaller mass, faster rotational velocity, spiral in shape. Their unique dispositions influence the resulting dynamics of the merger, including the formation of new stars, redistribution of dark matter, and the final configuration of the resulting galaxy. 8.5 Resulting dynamics. The kinetic expression manifests as tidal forces, shocks, and turbulence in interstellar gas, leading to bursts of star formation. Over time, the merger settles into a relative equilibrium, defined by a new resonant frequency that reflects the combined mass and energy distribution. Relative gravity in action. In the merging galaxies example, RGS principles transform traditional interpretations of gravitational interactions into a nuanced understanding of energy flow and harmonic resonance. 1. Spatial time. The merger occurs over a continuum of spatial time during which the galaxies share their resonant frequency potential. 2. Amplitude and superposition. The overlapping gravitational fields result in complex patterns of interference, dictating the flow of matter and energy. 3. Unique dispositions. Each galaxy's inherent characteristics shape the merger's outcome, creating a new, unified system that embodies the conserved principles of symmetry and dynamic equilibrium. The merging galaxies serve as a vivid illustration of relative gravity's abstract principles, by framing their interaction through potential energy, resonant frequency, and kinetic expressions subject to unique dispositions. RG provides a powerful lens to understand the cosmic ballet of creation, destruction, and transformation. This dynamic perspective emphasizes the interconnected, evolving nature of the universe, where even the largest structures adhere to the harmonic principles of RG. By Orion Carl Daly 24. Cookbook for the Universe 8.6 The Core Formulas of Relative Gravity, Unveiling the Symphony of Energy and Time. Relative gravity redefines how we understand the universe, integrating energy, time, and spatial dynamics into a unified framework. Its mathematical formulations are not just equations but expressions of a profound interplay between forces, dimensions, and entities. These formulas capture the essence of cosmic relationships, bridging microcosmic interactions and macrocosmic systems. Let us examine the three core formulas that form the backbone of relative gravity and explore their implications for understanding the cosmos. 8.6.1 Formula 1. The Averaged Energy-Time Relationship. This formula captures the essence of energy and time normalization across interacting systems, by averaging the square roots of energy and time parameters from two entities. The formula abstracts their combined behavior into a steady-state relationship, aligning with the concept of E infinity T infinity, the infinite or idealized state. Conceptual implications. The formula reflects a resonance between energy and time, harmonizing their fluctuations into a coherent state. This resonates with the broader principles of symmetry and conservation embedded in relative gravity. It emphasizes shared states between entities, suggesting that their interactions are governed by universal principles that unify their temporal and energetic attributes. Applications. Orbital systems. This relationship can describe celestial interactions, such as the Earth-Sun system, where the resonance between energy gravitational potential and time orbital period maintains equilibrium. Quantum interactions. The formula finds relevance in particle systems, where energy-time uncertainty aligns with a normalized state during interactions or decay processes. By Orion Carl Daly 25. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 8.6.2 Formula 2, Squared Energy-Time Ratios and Relative Equilibrium. This equation builds upon the normalized energy-to-time ratio E infinity T infinity, squaring it to signify the intensity of the relationship. The multiplication by relative equilibrium encapsulates the shared, dynamic balance achieved through interaction. Conceptual implications. The squaring of E infinity T infinity symbolizes the density or strength of energy-time coupling. Reintroduces a relational factor, embedding context-specific equilibrium into the equation. The result is a formula that captures the essence of dynamic balance across varying systems. Applications. Galactic interactions. When galaxies merge, their energy-to-time dynamics reflect a new equilibrium, governed by the overarching Re. Dynamic oscillators. This formula provides insight into oscillatory systems, such as electromagnetic fields, where energy density and temporal coherence dictate stability. 8.6.3 Formula 3. Relative Gravity Generalization. Here, relative gravity RJ is defined through a combination of energy-time ratios FTF and spatial scaling D. This formula synthesizes the components of energy, time, and spatial dynamics into a cohesive framework for understanding gravitational interactions. Conceptual implications. The inclusion of D introduces spatial variance, emphasizing that gravitational interactions are inherently dependent on the relative distances between entities. This equation unifies superposition, synchronized oscillation, and harmonic resonance. Bridging the Gap Between Classical Gravitational Models and Quantum Phenomena, by Ryan Carl Daly, 26. Cookbook for the Universe Applications. Cosmic Structures. This formula describes the interaction of large-scale systems like galactic clusters, where distance and energy-time coherence govern gravitational behavior. Localized systems, at smaller scales, such as binary star systems. The formula provides a nuanced understanding of orbital mechanics and energy exchange. 8.6.4 Merging Galaxies, a practical illustration. Consider two merging galaxies, A and B, as a test case for the formulas above. These colossal systems, each with distinct energy and temporal dynamics, interact over spatial time as they transition toward a new equilibrium. Formula 1. The energy-time relationship between the galaxies can be averaged to determine their shared E infinity T infinity. This reflects the normalized state they gravitate toward as they merge. Formula 2. The squared energy-time ratio multiplied by requantifies the strength of their coupling, highlighting the density of interactions and the dynamic balance achieved during the merging process. Formula 3. The generalized RG equation incorporates their spatial dynamics D, describing how gravitational forces evolve as the galaxies draw closer. In this scenario, superposition governs their overlapping energy fields, while harmonic resonance ensures coherence across scales, sustaining the dynamic interplay of forces. 8.6.5 Theoretical and Philosophical Reflections. The formulas transcend mathematical utility, offering a philosophical perspective on the universe's structure. Harmonic unity. These equations underscore the harmony inherent in cosmic interactions where energy, time, and space coalesce into coherent systems. Dynamic evolution. They reflect the iterative, evolving nature of the universe, where entities transition through states of equilibrium governed by relational dynamics. Bridging paradigms. By integrating classical mechanics, relativity, and quantum theory, the formulas represent a step toward unifying disparate scientific paradigms. By Ryan Carl Daly, 27. Aka. Essay on Relative Gravity to describe the mechanics of the universe. 8.6.6 The core formulas of relative gravity illuminate the intricate web of relationships that underpin the cosmos. By reimagining energy, time, and space as interconnected and dynamic, these equations provide a lens to explore the universe's deepest mysteries. Whether applied to merging galaxies, oscillatory systems, or quantum phenomena, they invite us to see the cosmos not as a static collection of entities, but as a living, resonant symphony of forces and dimensions. 8.6.7 Celestial Mechanics Example. The Sun-Earth System. Application. The first formula can describe the delicate equilibrium between the Sun's energy output, solar radiation, and Earth's orbital dynamics. Parameters defined. E1. The Sun's energy output, represented by the solar radiation reaching Earth. E2. Earth's reflected absorbed energy, encapsulating the planet's energy budget. T1. T2. Time scales governing energy exchanges, such as Earth's orbital period or its rotation. Calculation. This formula evaluates a steady-state energy-to-time relationship, enabling the prediction of Earth's stable orbit. It accounts for the rhythmic balance of forces maintaining Earth's position within the Sun's gravitational field. Potential insights. Orbital shifts. By analyzing variations in E1, for example, during solar maximum-minimum, this model could predict perturbations in Earth's orbital path. Climate models. Insights into Earth's energy balance are critical for climate modeling, as shifts in E2 absorbed reflected energy impact global temperatures and climate patterns. By Ryan Carl Daly, 28. Cookbook for the Universe. 8.6.8 Quantum Systems Example. Energy, time, uncertainty, and photons. The second formula, in application, finds relevance in describing quantum systems, particularly photon interactions. It extends the Heisenberg uncertainty principle by incorporating the concept of relative equilibrium. Parameters defined. E infinity T infinity, a normalized quantum state of energy per unit time for photons within a stable or infinite field. Squaring this ratio highlights the energy density within a resonant quantum state. Calculation. When applied to photon interactions or entangled quantum systems, this formula models the energy-time density at resonance. It captures the superposition of states, reflecting how energy and time are interconnected within quantum fields. Potential insights. Quantum entanglement offers a framework to describe energy distributions in relative equilibrium in entangled particle systems. Photon behavior deepens understanding of photon interactions, providing a quantitative approach to energy transfer within quantum superposition. 8.6.9 Cosmological Models Example. Black hole dynamics. Application. In the context of black holes, the second formula applies to the extreme energy-time relationships at the event horizon. Parameters defined. E infinity T infinity, energy-to-time ratio at the event horizon, representing the balance of energy and time near the black hole. Squaring this ratio and applying remodels the energy density interactions with surrounding spacetime. By Ryan Carl Daly 29. Aka. Essay on relative gravity to describe the mechanics of the universe calculation. This formula can describe the energy-time distortions in the accretion disk or the gravitational field surrounding a black hole. It provides a new lens to explore phenomena such as quasars or gravitational lensing. Gravitational lensing enhances models of lensing by quantifying energy-time distortions caused by massive bodies. Event horizon physics explains why photons cannot escape the event horizon by linking energy-time constraints with equilibrium states. Energy transfer in accretion disks provides a framework for understanding how energy radiates from matter as it spirals into black holes. 8.6.10 Synthesis across scales. These examples highlight how relative gravity as formulas provide a versatile framework applicable to a wide range of phenomena. A. Macrocosmic interactions, from the Sun-Earth system to black holes. RG captures the intricate energy-time relationships governing large-scale dynamics. B. Microcosmic behavior. Quantum systems benefit from RGS' ability to incorporate resonance and equilibrium into descriptions of particle interactions. C. Interconnected universe. RGS principles unify these domains, revealing a cosmos where every scale from the smallest photon to the largest galaxy adheres to the same foundational principles. 8.6.11 Philosophical reflection. Unity in complexity. These applications emphasize the holistic vision of relative gravity. The universe is a dynamic network where energy, time, and space evolve harmoniously. RGS formulas offer a roadmap for navigating this complexity, providing insight into the interconnected nature of existence. Through this lens, relative gravity becomes more than a theoretical framework. It is a guide to understanding the symphony of forces shaping our universe. 8.7 In review. How relative gravity's key ideas come together. Relative gravity, RG, brings together a collection of foundational principles and abstract models to form a cohesive and innovative framework for understanding the universe. By combining concepts of symmetry, object-oriented abstraction, and quantum dimensionality, RG offers a versatile lens for interpreting both macroscopic and quantum phenomena. By Ryan Carl Daly 30. Cookbook for the Universe. 8.7.1 Symmetry and randomness in universal forces. Core idea. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, share a foundational symmetry, with their differences emerging from the context in which they act. Dynamic symmetry. RG balances symmetry with randomness, suggesting that conserved properties, e.g., charge and vector harmonics, can adapt dynamically across scales. Implications. This symmetry enables the coexistence of seemingly disparate forces, uniting microcosmic and macrocosmic interactions within a single framework. 8.7.2 Object-oriented approach to forces. Programming analogy. RG draws on object-oriented principles like inheritance and polymorphism, where universal laws act as parent classes that give rise to varied objects, for example particles, galaxies, while sharing core attributes. Abstracting complexity. This abstraction enables forces and dimensions to manifest uniquely while retaining conserved, universal principles. Implications. Just as a programming class can instantiate multiple objects, universal forces emerge in diverse contexts without losing coherence, offering a scalable model for phenomena at all scales. 8.7.3 Unified relative force RF. Definition. Forces are normalized into a unified relative force RF, creating a framework to describe complex interactions across dimensions and scales. Applications. The Big Bang. RF provides a lens to describe the symmetry-breaking events that gave rise to the universe's diversity. Galactic and subatomic dynamics. From galaxy formation to particle interactions, RF unifies these phenomena through shared properties. Implications. RF simplifies the description of universal phenomena, creating a common language for both quantum and cosmic systems. 8.7.4 Quantum threads and dimensionality. Hypothesis. Quantum threads, such as ZR, interact to create dimensional constructs XYZ and the flow of relative time. By Ryan Carl Daly 31. Aka. Essay on relative gravity to describe the mechanics of the universe. Extensions to quantum mechanics. Resonance adds a layer of understanding to quantum mechanics by emphasizing the role of resonance and iterative cycles in the creation of dimensions. Relative time proposes time as a derivative construct influenced by the quantum interplay of energy and space. Implications. This model bridges quantum mechanics with cosmology, offering a new perspective on dimensional evolution and the origin of spacetime. 8.7.5 Manifolds as building blocks. Definition. Particles, galaxies. and other entities are treated as manifolds, dynamic systems that share common properties and evolve through interactions. Unified representation. This view integrates matter and energy within a scalable framework where properties like energy, time, and space are harmonized through symmetry and conservation. Implications. Scalable modeling applies equally to quantum particles and galactic structures. Contemporary relevance resonates with general relativity-esque curvature-based spacetime models while introducing a dynamic, relational perspective. 8.7.6 Atomic particles and radiative dynamics. Dynamic systems. Subatomic particles, for example protons, neutrons, and electrons, are not static. They radiate gravitational, electromagnetic, and nuclear forces. A. Relative equilibrium balances electromagnetic attraction with subtle gravitational influences, stabilizing particle interactions. Example: the electron s orbit around the nucleus is a manifestation of these dynamic equilibria. B. Periodic table reimagined incorporates radiative properties into understanding isotopes and bonding. Suggests the possibility of hypothetical particles with unique radiative dynamics, paving the way for discovering exotic matter. C. Implications redefines the building blocks of chemistry and quantum mechanics, expanding possibilities for material science and particle physics. By Ryan Carl Daly 32. Cookbook for the Universe 8.7.7 Mathematical Relationships and Conservation. Core formula. M1D2 equals M2D1. This expression of relative equilibrium highlights the importance of conservation laws within RG. A. Thermodynamic connections. Links conservation to principles like the Carnot cycle, emphasizing energy transformation and efficiency within cosmic systems. Suggests a deeper connection between thermodynamic cycles and universal dynamics. B. Implications. Cosmology provides tools for reinterpreting the energy balance in galaxy formation, black hole dynamics, and cosmic expansion. Quantum mechanics introduces a framework for integrating conservation principles into subatomic interactions. 8.7.8 Summary. Unified vision through relative gravity. Relative gravity represents an ambitious, integrative framework for understanding the universe. By combining principles of symmetry, object-oriented abstraction, and manifold interactions, RG bridges diverse domains of science and offers fresh perspectives on universal phenomena. Key contributions. Combines the deterministic symmetry with the probabilistic randomness. Integrates macroscopic and microscopic phenomena within a shared framework. Provides practical tools for exploring new frontiers in physics, chemistry, and cosmology. Through its unique synthesis of abstract principles and concrete applications, RG challenges traditional models and invites a reimagining of the cosmos as a unified, dynamic, and interconnected system. By Ryan Carl Daly 33.